A codec is nothing more than a kind of a fancy word for a compression algorithm. When you have limited space, you do what you can to try and cram more stuff into the space. None of them are taking lossless audio, packaging it up into the size package it needed to be, particularly, and sending it across the wire. The available bandwidth just isn't there to do it.
The speed of Bluetooth has actually gotten slower over time, which is pretty counterintuitive to me.
Well, roller coaster, yeah, it has.
Let's talk about why was it faster in the early days and kind of where
Bluetooth 2.1 had a maximum throughput of about 3 megabit per second. Realistic maximum was probably closer to 2. When they hit 4.0, that was the first LE, and we have to be careful about what we call LE here. Bluetooth LE and Bluetooth LE audio are two different things. Bluetooth LE came out at 4.0, audio came out later, so that's the first confusion. Bluetooth LE, let's start there. Bluetooth low energy. LE was low energy. First version of Bluetooth that was low energy was 4.0. Okay, so it came in, and the whole goal of 4.0 was to move the radio from an always on to a pulse, lower the amount of power it took to run it, and be able to extend the battery life without having to improve battery technology. Basically, it was a nod to the fact that, hey, batteries are as good as they're going to be without somebody else inventing this. What we can do on this side of the fence, as far as the Bluetooth design, is lower the amount of battery we use per unit time. So 4.0 was the big attempt to, how do we make this use less power? 4.0, on the other hand, didn't do much of anything with audio. When you look at the standard, it wasn't a focus. What we know as Bluetooth audio LE actually showed up at 5.2. LE audio is actually built on the 5.2 feature set. Didn't come out until 2020, so much later as far as the Bluetooth audio low energy. And it was done kind of in a response to the fact that 4.0 and some of the initial low energy things created some problems for audio. It did lower the bandwidth. You went from 3 megabit per second to a max of 1, so you got less room to work with. And really, that was where all these codecs that, the big part of this conversation started showing up left and right. Is a codec is nothing more than a kind of a fancy word for a compression algorithm. When you have limited space, you do what you can to try and cram more stuff into the space. We've done it for years, whether it's your house, whatever else. It's, how do I cram more stuff into the space?
Right.
All of these codecs are doing that. That's all they do. How do I cram more stuff into the available space? So when the space went down with the 4.0 standard, it became even more imperative that we have a better codec to be able to make the most of it. So, as it came back up, when we saw a 5.0 release, it comes back up to 2 megabit per second. So we've seen the ability to both combine the power savings that we saw start coming in at 4.0 with a little more bandwidth, so back toward what we saw in the original version. Not all the way to the 3, but we're up to 2 and a more usable amount of bandwidth within that framework. Okay. While retaining a lower power output.
Okay. So I think you're saying that the higher speed of the early Bluetooth drew too much battery, and it wasn't workable with wireless headphones.
And well, it wasn't workable with wireless in-ears, particularly where you didn't have the real estate to store a battery. But yeah, the big issue was that battery life was always going to be limited. And when we're looking at Bluetooth outside the realm of a consumer device like a headphone, we have to remember there's an awful lot of market out there that isn't headphone people.
Right.
One of the issues is that all these lithium batteries basically only charge so many times before they're dead, period. So a lot of the small lithium batteries generally have maybe 1,000 charge cycles total, which, again, if you're dealing with a headphone, charging it 1,000 times, probably 3 or 4 years worth of use, maybe not as big a deal. When you're talking about an industrial tool, that may be, a much bigger issue when you have thousands of them in a plant and they're all going to wear out. So a lot of the focus on this stuff isn't necessarily headphones. But yeah, we went from uses a lot of power, but has more bandwidth, to uses very little power, has very little bandwidth. And now we're working our way back up to uses very little power and has a bit more usable bandwidth to it in the 5 series. So realistically, that what we think of as 5.0, or I should say LE, in the audio world is LE audio, which is part of the 5.2 standard. Bluetooth SIG is a special or an interest group designed around creating a standard for Bluetooth. It is mostly industry members. So when you're talking about, it's not corporations, but everybody there has an agenda. It was actually originally brought out by Ericsson. It's been, somebody else has worked on it ever since, and it's always going to have some corporate, pull by various organizations. But we do see, you had originally, I think it was Ericsson and Intel and Nokia and Microsoft, and, and it's changed some since then, but it's still a lot of big corporate names in there that are helping develop the standard of where this gets pushed and where it goes next. But the idea behind it is an open standard. So even though there are corporations that are involved in the design and things like that, you're not paying a royalty to use the device. And the whole idea is to create a universal device. That goes back to where LE audio comes back into the picture.
Okay.
So we hit 4.0, bandwidth goes down, power usage goes down. So arguably we actually have a standard now that would let us develop a headphone or an earphone. But that bandwidth limitation becomes the problem. The built-in SBC codec in Bluetooth for audio left room for improvement. So what we saw happen then was this proliferation of improvements done by all sorts of companies on their own. So rather than go back to the SIG and say, hey, let's need some work.
Right.
We had Samsung did their own thing. Sony did their own thing. Qualcomm came out with aptX. We saw this proliferation of various improvement Bluetooth codecs that would sit inside that 4.0 framework, but all of them are proprietary. So you're paying Qualcomm, or you're paying Apple, or you're paying Sony, or you're paying Samsung for the privilege of using one of these various compression algorithms to get more across that channel than what SBC was capable of doing.
Okay, so let's start with SBC, because I think SBC,
it's the original, SIG,
is the original one. So all Bluetooth headphones, do they all have to be backwards compatible to that? So there's some interoperability, or
another dangerous question.
Dangerous question. Gotcha.
It is, but the answer is it depends. SBC, or subband codec, been around since the dawn of Bluetooth. And if you're in Bluetooth Classic, then it's always going to be supported. They now divided up between Bluetooth Classic and Bluetooth LE. And an LE device, this new generation of device, does not technically have to be backward compatible to SBC. In most cases, they are, simply because it's advantageous to the manufacturer to give you as broad a range of connectivity as they can. But again, even to that, is it required? Now, it's possible to find devices that don't support it.
Let's go from SBC to AAC, which is Apple's version. I believe this is an Apple proprietary version of a similar technology to SBC, but it only works with Apple products.
Right. AAC, advanced audio codec, standard for iPhone, iPad. Interestingly, there are a lot of Android devices and other things that support it, but it's another, another compression algorithm to try and get more of the original signal into the package. There is a trade-off on all of these. None of them are taking lossless audio, packaging it up into the size package it needed to be, particularly for Bluetooth 4.0, and sending it across the wire. The available bandwidth just isn't there to do it. So everybody was trying to come up with a better mousetrap of how do I get the best sound out of what I've got available to me. AAC was Apple's version.
Okay.
The other big two in the market were aptX, which was
Mm-hmm.
Qualcomm's version of it.
Gotcha.
And that one is further muddied by the fact that they have about 5 versions of it now. The first one was aptX. Next generation was the HD and the low latency, which were kind of competitive with each other. HD was putting more of an emphasis on bandwidth for music. Low latency was putting more of an emphasis on synchronization for gaming.
Okay.
So if you wanted to make sure that the sounds were aligned with the video, you use low latency, but you might not get quite the the detail out of it that you would with the HD. But with HD, you might suffer a little more latency. So there was a trade. As they move forward now, the newest one is aptX Adaptive, and as the name suggests, basically it's a mixture of what they've done to date, and the idea is that it's smart enough to know which one's which, and adjust on your behalf.
And I think aptX has also announced aptX Lossless, which I don't know if it's really lossless or it's approaching lossless, but lossless is in the name.
It is, and that was it was announced in late 2021. I want to say September, October time frame.
Mm-hmm.
And the real issue there has been that it has to have support out of both the source and the headphone to work. And there are not a whole lot of examples of it out on the market. So, and again, even within that framework, to your point, looking at it, it is possible when you're up to that 1.2, 1.3 megabit per second of the 5.0 standard to get lossless if you're looking at 1644.
Right.
To get CD quality. So yeah, technically there's enough bandwidth there to get CD quality across the line. So it's not impossible. Difference is when you start looking at lossless at 2496 or the higher bit rates and depths.
Right.
Yeah, no, bandwidth isn't there. So there's still some, still limited, but yeah, I don't think they're lying. I just think they're maybe a sin of omission in the respect that they're saying only in this circumstance.
Right.
But that, aptX is Qualcomm's proprietary. And one of the things you end up looking at is who do you pay for this? So if you use AAC, you're paying Apple. If you use the aptX, you're paying Qualcomm. Well, Qualcomm sells probably, I don't know, 75, 60% of the radios for Bluetooth, period. They're a huge player in that market. Don't send me hate mail on exact numbers, but they're a huge player in the market.
Right.
So people don't necessarily think about the fact that you're licensing the technology as part of buying the part.
Right. Right.
And
all of them, as you alluded to, they all have to have the source device and the receiving device have the same technology built in. So it has to be, so for example, Apple does not support aptX. So if you buy aptX earphones, you're not getting whatever the aptX signal can do. You're getting whatever subset of that.
Chances are it's going to drop back to AAC because Apple's a huge part of the market. So everybody supports AAC.
Gotcha.
Most vendors don't want to lose that big a market chunk to not do it. But, there is a possibility that it drops back to SBC just because it doesn't have any other option.
And the customer and the consumer has no way of knowing what it's actually doing.
Not true.
There is a way to find out.
There is.
Okay.
It's actually real easy on Android in that you can go in the developer options and it'll let you, or there are a couple of apps out now that'll actually show you, hey, this is how I'm connected. So you can actually view that. With Apple, depends on the application, but yeah, some of them will tell you how it connects. So it is something you can detect. But yeah, at any rate, back to the point, which was with Qualcomm selling the chip, a lot of times people don't realize that part of that cost is the license, and it is. So it's a proprietary technology. It just happens to be embedded in the chip that a lot of manufacturers use anyway. LDAC is probably the exception to that. LDAC's a Sony design, and you have to directly pay Sony to use that. So we see them with Apple, with Samsung, with Hawaii, with several of the LHDC that's a little lesser. No, most of them are competing standards. Nobody's released theirs into the public domain yet. So for all of these, you're paying somebody else to be for the privilege of using their codec.
So I think you're saying with every earphone, every true wireless earphone that's sold, that manufacturer is paying a license to Apple to, if they want to support all these codecs, to Apple, to Qualcomm, to
Sony, to whoever else, right?
Whoever else.
Samsung Scalable, whoever.
Right.
That's where your new one comes in. When we start talking about Bluetooth LE audio.
Okay.
Now we have LC3, which is the
next evolution of SBC, right?
Right. Well, the next evolution of the standard protocol, right?
This is from the Bluetooth SIG standard. Now, this is supposedly going to supersede all the other proprietary standards, and this could be a common one that nobody has to pay a license for.
Right.
Is that correct? So, and they could all work together.
That's the idea, right? The LC3 is a low power audio codec. It's like they call it the low complexity communications codec. So LCCC or LC3. And it brings a lot of the same things that we've seen with aptX adaptive, with LDAC, with some of the lossless codecs into the standard. So instead of having to pay another license on top of it, it's now part of that, which theoretically speaking, what you said a minute ago, ought to mean it's more universally available. It's not yet because it's brand new and a lot of things haven't caught up. But as it phases in, the idea is it should supplant all of these competing standards out there, and that it provides the same functionality without an additional license. Of course, you may see some fight from Qualcomm since they make a lot of the chips.
Right.
Their standard may die hard here, where they may include both, and that if you're going to support the LE standard, you have to support LC3, but it doesn't say that's the only thing you can support. So they may actually continue to produce a competing standard.
Gotcha.
So we may not. I don't think we're going to see them go away tomorrow because Apple and Qualcomm and some of these have a big investment in them. But at the same time, the goal of this was to unify it so that a Bluetooth headphone would work with a Bluetooth source device and not having to go through, well, mine's aptX, is yours AAC, or I've got Sony, doesn't talk to my Samsung.
Right. And then we were, there are also more features as part of Bluetooth LE that are part of the new, can you speak to some of those and what are some of the extra features? Yeah,
absolutely. As we start looking at LE in general and LE audio in specific, there are definitely more features to it that we want to kind of keep in mind. First off, 5.2 was the introduction of LE audio. So that's a big, sort of checkpoint for us in the audio world of it has to be 5.2 or newer to support LE audio. So
if you have a device right now that's Bluetooth 5.2, which there's a lot of out there right now, I think the new iPhones are 5.2, I believe.
Yeah, 5.2 has been around since end of 2019. So it's made some permeation in the market, and there are devices out there that have LC3 support, have LE audio support. But so when you're looking for that, if you want something with LE audio, make sure it's 5.2 or newer. 5.3, 5.4 really aren't focused on audio. The changes from 5.2 moving forward into 5.3 were channel enhancements, the periodic advertising changes, things like that were more designed for industrial use. With 5.4, very much so. 5.4 did something. Their big selling point is what's called periodic advertising and responses, which is basically a way to put Bluetooth inventory tags on products and have them periodically check in. So for a store where you're doing inventory, something like that, big change, big deal for them. For audio, don't care, right? Probably never going to be something we use. Changes in the audio side are almost as dramatic in some respects, but again, may or may not be something you use. The first one, the big changes, there are Auracast broadcast audio. And, what's happened up to now is that we've seen data transfer and Bluetooth handle point to point, handle broadcast, handle mesh. When you went to audio, it was point to point only. You didn't have that, ability to do the broadcast or the mesh for audio. Now you do. Now, is that going to be a game changer for a lot of us? Probably not. We were talking before. Right. Well, we were talking before we started this.
Yeah.
Silent disco kind of thing. A museum where you have a tour group where you could hand out earbuds and run a guided tour through the museum kind of thing. It's perfect for those scenarios. For those of us that use it at home, unless you just have a whole bunch of friends that want to listen to the same thing on their, each of their own headphone, maybe not as big a deal. But that's one of the new ones.
Well, you're still limited by the 100 feet distance, right? Like you still have to be within 100 feet of the source.
It's a little more. It's a little more than that. It depends on 100 feet's probably reasonable to say, but realistically, in open space, you can probably get more out of it than that. It just depends. A lot depends on the barriers, the obstructions, the things like that.
Right.
Technically speaking, I think the 5.0 range for Bluetooth is limited as up to 400 or listed as up to 400 meters, which is extremely so optimistic, I think.
So there's some type of data that gets to 400 meters, but not the full audio signal.
Right. And that's one of the things we're going to run into. That's also one of the things that we've seen over and over again is the longer you go, the worse it gets. So there is a realistic limit of how close you have to be to the radio. But one of the things we've seen with the enhancements here is the connection switching has improved. So you can move from one radio to another and actually continue to follow it. So that, again, for things like museums or that kind of thing is probably part of the discussion. The other one that may be something we see more of, changes for hearing aids. We're seeing some, changes that will be productive for hearing aids, and that it does lower the amount of power needed, as well as supporting multi-stream, which is important in that if you want to get both ambient sound and, a stream coming in or that kind of thing, that multi-stream capability is going to be interesting to see. So, that's one of the things that we've seen too, is that, with multi-point Bluetooth, it's been around a little while now. I can switch between my phone and my laptop. It hasn't been, I can use both simultaneously. Right.
If they can get the pairing right and simple to where you never have to think about pairing again.
Or which device you're connected to.
Right. So you can have all of your headphones, you can have multiple headphones, and whichever one you put on, it senses that it's on your head and it's looking for a signal and you can hear it. Like that to me would be the ideal place to get, which, I've always been frustrated by the connection of Bluetooth. I think everybody has.
Yeah, I think that's the promise of it. And the other piece of that, of course, is that when you start doing multiple streams, again, you have a limited amount of bandwidth available. So 2 streams means half the bandwidth for either one, 3 streams, a third of it, so forth and so on. So there's going to be a realistic limit of how many of them you can use simultaneously.
Right.
But it would be nice to be able to take a phone call while still hearing your background music and not have to switch back and forth and be conscious about it. So I think within that limit, we're going to see multi-stream come in and do good things.
So is multi-stream different than the broadcasts? Because I guess I have it in my head. So if you're broadcasting, you're sending out the full signal to who's ever in the range and whoever.
Right. And broadcast. Broadcast, basically, you can think of it as this way. Broadcast is one source, multiple endpoints. So whether we predefine them and say these people are allowed to get it, or whether we put out in public and say anybody who can hear the radio can have it, broadcast is exactly what we'd think of with broadcast television, broadcast radio. It's coming from one source, but it's sent out to whoever wants to hear it. Gotcha. With multi-stream, it's the opposite. I can have 10 different sources all feeding this one device.
I see.
So it's similar concept, opposite direction.
So is this going to help with stereo over Bluetooth or multi-channel spatial audio over
We,
Bluetooth?
we may see it help with spatial audio in some places where you can divide up and work with that. It depends on how the radios are configured. And I think that part of it, there's a lot of talk about it in the market right now about things people are doing with it, but that's, until we see it come out in finished products, it's tough to talk about. So I think we'll see some of that, but I don't think we're there yet. So,
Gotcha.
but yeah, there's some interesting things in the audio world. But like I said, the other thing we have to remember realistically is that just because a new Bluetooth standard comes out doesn't necessarily mean that there's anything in it that's audio interesting.
Mm.
So realistically, 5.2 was the LE audio standard. 5.3, 5.4 have some improvements, but not necessarily anything in audio that would make me jump and run and say, okay, this new headphone came out with a 5.4 Bluetooth chipset, I have to go get it.
Right.
You know, now the difference between 5.2 and 5.4 is probably negligible from an audio standpoint. So
what's your take on all the earphones and headphones that say they're high res certified or high res wireless certified? How do you respond to that?
I respond to that by saying I have yet to see anybody come out and tell me exactly what it means to be high res. So I don't want to say people are, you know, outright, well, lying for lack of a nicer term.
Right.
But I think the difference between what one person calls high res and somebody else calls it is remarkable when you start really digging into the fine print and things like that, and the lack of fine print in a lot of places where they, oh yeah, it's high res. Well, what does that mean? Well, I don't know. You know, there's a limitation.
I think I know what they're getting at. I think what they're trying to say is perceptually it's high res in the fact that if you played the high res version and you played the whatever the compressed version is, you wouldn't be able to tell the difference. So we'll just call it high res.
I think that's a lot of it. And I think it's a marketing tool. It's, you know, and in large measure, you know, there's a lot of that goes on in this industry. You know, when we talk about trying to do an accurate reproduction of sound, what we're really talking about is trying to reproduce what you call an accurate definition of sound.
Right.
And the problem is your definition and my definition and Ian's definition and Lynn's definition and Eric's and are all probably a little different.
Right.
So it's a moving target. And I think very much so with this high res audio, it's more of a marketing tool than it is a standard.
So we're still limited by the bandwidth of Bluetooth. We can't, no company can exceed that. They're not going outside of Bluetooth. There's no extra radio signals or data communication that's happening. Whatever the Bluetooth standard can offer, everybody has to work within, and that degrades over distance and objects and potential obstacles.
Yeah.
Right. And like
obstacles, interference. Yeah.
Right.
If you don't believe Bluetooth can easily be interfered with, put in a set of Bluetooth headphones, stand next to your microwave. 30 seconds will convince you that yes, Bluetooth can be interfered with. You know, that's yeah. There are. Go
ahead.
There are all kinds of things that play games with it, and then that, you know, change for better or for worse how it behaves. If nothing else, the other thing, you know, you get on an airplane, you look around, and everybody has their headphones on. Well, guess what? You're all competing. You know, it's probably not going to work as well as it does in a quiet room, you know, where you're the only person within 300 meters of the Bluetooth device.
Right. No, all depends. That's a good point. That's a good point. Just the number of Bluetooth devices in your area has an impact on the signal, because Bluetooth shares the same spectrum.
Right. It's frequency.
Frequency spectrum. That's what I was.
Yeah, as I say, it's frequency spectrum, and not only does it share the same frequency spectrum, it's a very narrow spectrum. You know, there is not a whole lot of extra room there to. Basically, you've got between 2.4 and 2.48 gigahertz is the Bluetooth frequency range. I think technically it's like 2402 to, you know, 248 something or other, but.
Right.
You know, it's a very narrowly defined range, and it does a lot of things to keep it from being interfered with. You know, we were talking about frequency hopping and some of the things that it does which are trying to eliminate those sources of interference that become a problem. And it does an admirable job of it most of the time.
Right.
The problem is sooner or later it does get congested, and there are things that are going to fight with it. And your proponents of wired headphones are going to smirk at this and go, "Yeah, mine never had a problem." But the reality is there's a trade-off of convenience for some of those things. So
Right.
yeah, how many devices are you going to be? Yeah, it depends on the situation, how high powered the other devices are, the proximity of the device. There are too many factors to definitively give one answer.
Well, I know you test a lot of headphones, a lot of wired headphones and a lot of wireless headphones. How close is the current standards that we're at now?
Very, very close. And I'm going to get beat up for saying that, but I'm going to say it anyway. And here's the reason I say it. For the same reason I have always professed, I go to audio shows to see what's new in the market and things like that. I don't go to audio shows to listen to anything, because there's so much traffic and so many people doing so many things and stuff like that it's just not realistic. Right. Well, so here's my, to qualify my answer. The best headphones I've ever heard are still all wired. Okay? Right. Unless you have a quiet room and a very good source, okay, you can't tell that's the best headphone you've ever listened to. If you're in a noisy environment or your source quality is less or things like that, all of these things play into that. So, when you talk about the use case for a lot of these wireless headphones now, I'm wearing it on the bus, I'm wearing it on the plane. It's for, my commute time. I'm wearing it at work where they got a white noise generator in the background. All of these things are not conducive to doing critical listening anyway. So when you start factoring those things into it, yes, there are some extremely good wireless headphones today. I look at the Focal Batiste that I really like, the Bowers and Wilkins PX7S2, PX8, fantastic headphones. The recently reviewed Bang & Olufsen, their H95 that I think went up here a couple of weeks ago. Also right there, Levinson's 5909. The number of choices of headphones that are true wireless and very capable is increasing tremendously. I don't think there was one I would have said competed with any of those a year ago. All of those are recent introductions, and all of them are amazingly good for the kind of things that we use headphones for every day. Are they going to replace your LCD5s? No, they're not going to replace your LCD5, but you're probably not taking your LCD5 on the bus or the plane or all those other things we talked about. So are they as good? Technically, probably not. Realistically, yeah, they probably are.
Right. What do you think has led to this major jump in wireless?
I think there are a number of factors that are playing into it. Some of it is technology. We've seen improvements in battery. We've seen improvements in system on a chip designs that allow you to take what took 7 or 8 parts that are now in one cast in one die. So it's miniaturized a lot of the electronics and made it easier to do some of those things.
Right.
Some of it's that, and some of it is pure and simple demand. And I look at it and say, I was one of the naysayers there for quite a long time. I looked at it and said, I've never really had that big a problem with the wire between my headphone and my DAP. Bluetooth was kind of a solution looking for a problem. So I went for a long time where I said, I really don't know that I need Bluetooth on any of my stuff.
Right.
Well, then one day you start playing around with it and you realize that, you just got up and walked down the hall and did something else and your music's still playing and you left the DAP on the table. And it's one of those, that's actually kind of convenient, and it's not a huge thing, but it is a convenience factor. And I think what's happened is more and more people have come over to the idea that, the convenience really is worth having. And, the audiophiles are always going to be the holdout to that, because there's always that, like I said, they're not quite as good as some of your wired headphones, but they're to that point where they're good enough for what we do 90% of the time that you wouldn't know the difference. quick shout out for our next time, and that is we're going to talk to Packet Craft here in a few weeks. And if you really want to know about Bluetooth audio, these are the guys. Tune in for that one.